Our next topic is mesh analysis. Solving a circuit using mesh analysis is based on Kirchhoff's voltage law. What is Kirchhoff's voltage law? The algebraic sum of the voltage drop across each element in a closed loop is equal to 0. Now, for doing the problem on here, we need to know first how many number of meshes are there. Before going to the mesh, what is a mesh? A mesh is a loop that does not contain any other loops within it. So if you have a closed loop, no other loops are inside that is called a mesh. Mesh current is a current that flows around the perimeter of the mesh. Suppose if you have a circuit which contains m meshes are there, then there will be m currents are there, m unknown currents will be there, and we can get m corresponding equations based on that. So for doing a circuit using mesh analysis, we have to follow these steps. First, we have to identify how many number of meshes are there, and after that assign mesh current to each mesh. Suppose 3 meshes are there, you can assign current say I1, I2, I3 to each mesh. Then you have to apply Kirchhoff's voltage law to each mesh, and all of you are familiar with Kirchhoff's law by unit 2, unit 1 and all. Now solve the system by using the system of equations you are obtained from the KVL. See, here is an example problem. As shown in the question, you have to determine I1 and I2. Current I1 is this one, current I2 is this. Look at here, how many meshes are there? Mesh is a closed loop. Inside that, no other loop should be there. See here, how many meshes? 1, 2 and 3 meshes are there. So the first step is over. Identify the number of meshes in this question. And now we have to assign mesh currents. As already there in the question, it is given as I1, I2 and I3. I1, I2 and I3 are the meshes current. If it is not given, you have to assign that each mesh current as, suppose 3 meshes means 3 currents, say I1, I2, I3 or IA, IB, IC, it's up to you. So now we'll start our problem. So we identified here 3 meshes, 1, 2 and 3 meshes are here, 3 closed loops, and assign the current. Already it is assigned in the question itself. It is I1, I2 and I3, the 3 currents. Now the third step is we need to apply KVL. For applying the KVL, we need to know what is each branch current. So as we are taking this mesh first, this is current I1, it is going up here. I'll just mark it as this is I1 going up. Right side also it is I1. Now coming to this branch, see I1 is coming down here and I2 is coming up because this branch is common to mesh 1 and mesh 2. So in mesh 1, I1 is coming down, in mesh 2 I2 is going up. So if I am assigning the current in downward direction, this one, so downward direction you have I1, then upward direction you have I2. Because I am taking downward direction, so I1 in the same direction of I1, so I1 should become first, I1 minus I2. That is a branch current in this. Now see here, this branch alone I2 is flowing. So this current is, I'll mark it as I2. This branch also I'll mark it as I2. Now see here, this branch is 10 ohm resistor branch is common to mesh 2 and mesh 3. So mesh 2, the I2 is flowing in this direction, and mesh 3, I3 is flowing in this direction from left to right. This is from right to left. So if I am assigning the same direction of I2, I just mark it as this. So this current I should write as I2 minus I3. It is I2 minus I3. Now see this branch I3 alone flowing, that is flowing downward, I3, and this branch also I3 alone flowing, so this I3. This branch I don't want to consider the current because already the voltage source is given. Now what about this branch? If no elements are there, if an element is there, this branch current is same as I1, like this. So I1 is flowing like this. So these are the current directions for each branch. Now as per the direction, I am going to mark the polarity of resistors. Now see here, polarity of a voltage source, take it as same as given in given. Now only the resistor now we need to mark. This branch 5 ohm current is entering in this direction. So I'll mark this as plus and this should be minus. For this, flowing down, plus minus. Like this I am taking, so this is plus, this is minus. It is down, plus, minus. This is also down I am taking, so this is plus, this is minus. Now based on the assigned direction, just apply KVL. Based on the assigned current direction, you need to apply KVL on each mesh. So that's the way we have to write now. We are going to write now the KVL equation. So in mesh 1, first in mesh 1 I am going to apply the KVL. So in mesh 1, see this is mesh 1, current is in, assigned current is in this direction. So minus to plus, plus 10. Look here, no elements here. Here comes plus to minus. It is minus 4, current is I1 minus I2. Comes here, it is coming down a same direction. So plus to minus, it is minus 3 should be equal to 0. So when we are readjusting the equation, we will be getting it as 10 minus 4I1 plus 4I2 minus 3 equal to 0, or I can write it as 4I1 minus 4I2, 10 minus 3, 7 is equal to 7. Equation number 1 for mesh 1. Now apply KVL to mesh 2. So mesh 2. If I am applying KVL to mesh 2, plus to minus, minus 5I2, plus to minus, minus 9I2, coming here plus to minus, minus 10, the current is I2 minus I3, I2 minus I3, minus to plus. Now see here, the branch current I1 minus I2 is downward direction and our assigned direction is upward. So I will go according to our assigned direction. When I am going minus to plus, so it become plus 4 I1 minus I2. There is no voltage source, so should be equal to 0. So now readjust the equation, minus 5I2 minus 9I2 minus 10I2 minus into minus plus 10I3 plus 4I1 minus 4I2 should be equal to 0. So readjusting that, we will be getting it as 4I1 minus 28I2 plus 10I3 should be equal to 0. Mark it as equation 2 for mesh 2. Now coming to the third mesh, mesh 3. So mesh 3, when I am taking, this is the same direction. So minus to plus, plus. The resistance is 10. The current is I2 minus I3. I2 minus I3. That is the branch current we marked before itself. According to that, we have marked the polarity of resistor. So it is now just like a voltage source with a pre-marked polarity. Now according to the assigned direction, we need to write the equation alone. So minus to plus 10 I2 minus I3, plus to minus 1 I3, plus to minus minus 7 current is I3, minus to plus 3 should be equal to 0. So after readjusting the equation of mesh 3, we will be getting it as 10I2 minus 18I3 is equal to minus 3. So now we have 3 equations corresponds to each mesh. Mesh 1 that equation, then mesh 2 this, mesh 3 this equation. So now for the 3 equations we have 3 unknowns, I1, I2 and I3. As per the question, we need to calculate I1 and I2. So for getting it, now it become 3 unknowns. We can get the answer by using a 3 by 3, writing a 3 by 3 matrix and solving it. So now we'll do that. So the 3 equations, we are writing the matrix, write the coefficients of I1, I2 and I3. So first equation, I1 4, I2 coefficient minus 4, no I3, so 0 is a coefficient, should be equal to 7. Second is 4 minus 28 and 10. Fourth one, there is no I1 coefficient, so it is equal to 0. I2 it is 10 and I3 coefficient is minus 18. Now for solving this, for getting I1, I2 and I3, we don't want to calculate I3 here as per the question. So for getting I1 and I2, first we need to calculate the determinant, delta. Delta is 4 minus 4, 0, 4 minus 28, 10 and 0, 10 minus 80. So when you are writing the determinant, first 4 I am taking, so this multiplied by this. So it is minus 28 multiplied by minus 18 minus 10 into 10. Now that first element finish. Second is minus 4. So this row and this column and this row will be eliminated. So 4 into minus 18 and 10 into 0. So minus 10 into 0. Now this is plus, this is 0 into this means it is 0 only. So 4 into 10 minus 28 into 0. So when you are solving this, we'll be getting it as around 1616, this one, minus 288. So the final answer will be 1328. That is your delta. Now you will need to calculate delta 1. Delta 1 means replace the first column by this 70 minus 3 and get it. So when we are solving delta 1, we will be getting it as 2948. Delta 2 is 624. So we want to get now I1 and I2. So I1 is equal to delta 1 divided by delta. So we know delta 1 is 2948 divided by delta is 1327, I think 1328. 1328. So it is 1328. So it is solving, it is 2.2 ampere around will be getting. Now we can calculate I2 as delta 2 divided by delta. Delta 2 is 624 divided by delta is again 1328. So we'll be getting it as 0.469 around, 0.69 ampere. So this is our I1 and I2 as per the question. So by using mesh analysis, this is the way we are solving the circuit problem.